When we travel from point A to point B on Earth, we just go in a straight line. That's the fastest and easiest way to do things. But in space, to get from planet A to planet B, our path is going to look a little bit more like this. Why is it like this? And how do orbital dynamics come into play? When one thing orbits another thing, let's just look at the moon orbiting Earth, it has both kinetic energy and gravitational potential energy. Now, we can imagine kinetic energy as relating to speed. As the moon goes faster, there's more kinetic energy. The gravitational potential energy is related to the distance between the two objects. So if the moon and the Earth are really close together, that means that there's less gravitational potential energy. And if they're really far apart, that means that there's more gravitational potential energy. At different points in the flight, the individual values of the different types of energy might change. It might be more gravitational or more kinetic at any point. But the total amount of energy between the two types is always going to be the same. That last bit was super important to understanding how orbits work. At some points in the orbit of a satellite or moon, the satellite or moon is closer to Earth, which also means that gravitational potential energy is way less than at other points. When the gravitational potential energy is low, the kinetic energy has to be higher, so whenever a satellite is close to Earth, it means it's going faster than it is at other points. Now it's time for the interesting part. We can establish orbits using the principles we just talked about. If we go up pretty high off of Earth, we can start going in a direction tangential to the surface of the Earth. That just means not pointing into or away from the surface of the Earth. And if we just start going really fast here, we're increasing our kinetic energy, which brings our potential energy on the other side of our projected orbit path up, which means that eventually it'll form a stable orbit. That energy has to come from somewhere, and we're taking it from the chemical energy in the rocket fuel. We're choosing this specific time at the top of our flight path to use this chemical energy, turn it into kinetic energy, and increase our potential energy on the opposite side of our flight path. Now, I love orbiting Earth as much as the next person, but if we want to actually get to the moon, there's a couple more steps we need to do. First of all, we need to wait until we are on the opposite side of Earth's orbit path from where the moon will eventually be, because remember, the moon's still orbiting too. From there, we just speed up in the same direction that we've been going to build up that kinetic energy so that the potential energy that has to build up as a result is pushing our orbital path closer and closer to where the moon will be. And at this point, we just wait, and the moon will eventually grab us at the far end of the path. And now that we're sort of in the moon's influence, we just start accelerating in the opposite direction to decrease kinetic energy so that our potential energy also decreases and the path of flight eventually collides with the surface of the moon. And we can also collide with the surface of the moon